Hi everyone, I am Muhammad Abuzar and you are watching Zarmath, and today we're gonna discuss an important lecture on calculus, and that is the limit of a function. So what does it mean by limit of a function? So before defining it formally, I would like to share that what is the purpose of limit of a function, why we need it. So limit of a function means sometimes when we are discussing some functions, we are interested to check the behavior of a function at some particular point. For example, we have a function f of x square minus 4 divided by x minus 2. So this is a function, and we want to check the behavior of this entire function at x equals to 2. So what will happen when we substitute at x equals to 2 in that function? So f of 2 equals to, we have substituted 2 in x minus 4 over 2 minus 2, which results in 4 minus 4, 2 minus 2, and that is 0 over 0. So we have just observed that this function at a specific value, which is x equals to 2, when we substitute x equals to 2 in that function, we get an undefined answer. So this is undefined. So how are we gonna check this? So we will check the behavior of this function at some neighborhood of 2. So this leads us to the concept of limit of a function. So you have observed that we want to check the behavior of this entire function at x equals to 2, but now we have seen that this is undefined. Means we have no information what will happen when we substitute at x equals to 2 in that function. So this will lead us to the concept of limit of a function. So in short, what is the purpose or why we use limit of a function? Just because we want to check a specific value. If we put a specific value in some function, so what will happen? So now when we substitute 2 in that function, we get no information. So what if we choose some neighborhood of this point 2 and then substitute this function? So now that pattern will give us information what will happen when we substitute at x equals to 2. So let's suppose we have function x square minus 4 over x minus 2. So when we substitute 2, we have no information. So now we gonna choose at x equals to 1.5, because 1.5 is very close to 2. So we want to check that what will happen at some neighborhood of 2. So 1.5, f of 1.5 will be equals to 1.5 square minus 4, 1.5 minus 2. So I have already calculated this entire function just to save your time. So you can also check it. That will be equal to 3.5. We will just increase one more step, f of 1.6. Now we have gone little bit further from 1.5 to 1.6. 1.6, we are substituting 1.6 in x in that function, minus 4 over 1.6 minus 2, that will give us the 3.6. I have already calculated it. And what will happen when we substitute f of 1.7? Means 1.7 square minus 4 over 1.7 minus 2, that will lead us to 3.7. Also when we substitute f of 1.8 in that function, so what will happen? We will put 1.8 in that function, 1.8 square minus 4 over 1.8 minus 2. So that will lead us to 3.8. Okay. And also f of 1.9. So this is the last value that we will substitute, because 1.9 is much closer from this point. f of 1.9 means 1.9 square minus 4 divided by 1.9 minus 2. So this will lead us to 3.9. So now you have observed a pattern. So what kind of pattern this is? When x is approaching towards 2, we were started 1.5, then 1.6, 1.7, 1.8 and 1.9. So this value of x is approaching towards 2. From here 1.5 to 1.9, this is very close to 2. X approaches to 2, then this f of x, the final answer of this function, is approaching towards 4, means f of x is approaching towards 4. From that example it is clear that when we are going closer and closer towards 2, the final answer of this function is approaching towards 4. So this is the basically limit. And how you will write it? You will write it limit when x approaches to 2, when x approaches to 2, the function x square minus 4 divided by x minus 2 goes to 4. So this is the limit concept, and now we formally define from this that how you will define limit of a function. So now after that example we formally define limit of a function. So let f of x be a function defined in an open interval near a number a. F of x is a function and is defined in an open interval. If x approaches a, f of x approaches to a specific number L, then L is called the limit of a function. So this is the formal definition of a limit of a function. So what does that mean? F of x is a function. We can choose any function. So and is defined in an open interval near a number a. If x approaches a, if f of x approaches to a specific number L. So just come back to the previous example. If x approaches to 2, in that example f of x approaches to 4. So this is x approaches to a number a, let's suppose, then f of x is approaching to a specific number L. So this is the definition of a limit of a function. Symbolically you will write limit when x approaches a, f of x will approach to a specific number L, and that specific number L will be called the limit of a function. So now we will discuss that in how many ways we can approach to this number a. So let's suppose I draw a real line here and we have a number 2 in the center now. So we can approach 2 from two sides, either from the left side or from the right side. So we have two possible options in the real line. So when we will approach from left side, we will call it left hand limit, and when we will approach from the right side, we will call it right hand limit. So this is just a basic concept. I am not gonna define it formally. So when we will approach from the left side to this 2, we are using left hand limit, and when we are approaching from the right side, we will say it is a right hand limit. So how we will mathematically write the left hand limit? That will be limit x approaches to, let's suppose, c, and then we will put a negative sign on it, f of x, and that will approach to a specific number L. So what does that negative sign is indicating? It's just indicating that we are approaching from the left side. And when we will use right hand limit, we will write it limit x approaches to c, and now we will put it on the plus sign. that will be equal to f of x. So let's suppose it is approaching towards m, any specific number. So here plus sign is indicating that we are approaching from the right side. So this is the limit of a function. We want to check the value of the function at a particular point. So that was the function, and we want to check it at x equals to 2. So we have observed that when x is approaching towards 2, the f of x is approaching towards 4. So this is not only the one way to evaluate limits. There are several other ways to find out the limit. So one is using algebraic techniques, or the other is rationalize, and there are also many methods. So today we will just learn how to evaluate the limits by using algebraic techniques. So let's move on it. So now we will evaluate different functions by using algebraic techniques. Now by using algebraic techniques, how you will solve the how you will evaluate limits. So this is the same question that we have already done. So how we will solve it by using algebraic techniques. So now limit x approaches to 2 x square, and this 4 can be written as square of 2 divided by x minus 2 as it. So limit x approaches to 2. Now this is a negative sign in between the two squares, so we will just call it a duplicate step, and we will do that. First we will write in plus, and then we will write it with negative sign, and also x minus 2 as it. So now you have seen that x minus 2 will get cancelled by x minus 2. So what we will left here, x approaches to 2 x plus 2. So how you will solve this? You will just simply substitute x equals to 2 in that function. So x equals to 2 in that function means x equals to 2 plus 2, this is 4. So this is a very easy way and simple and also convenient for the students to evaluate limits of this question. Limit x approaches to 2, that function was given, and now we have used algebraic technique. Also now come to this question. Limit x approaches to minus 1 x cube minus x over x plus 1. So now we solve it. Limit x approaches to minus 1. So let's take x common in numerator. That will lead us to x square minus 1 divided by x plus 1. So limit x approaches to negative 1 x as it. So now we can write x square also square of 1. So it is always 1 x plus 1. So limit x approaches to negative 1 x into, we will also do the same step, as there is a negative sign in between the two squares. So we will first write it with plus sign, and then we will write both values with negative sign. X plus 1 will be in denominator as well. So x plus 1 will get cancelled out by this x plus 1. So limit x approaches to negative 1 x of x minus 1. So let's substitute x minus 1 here. So x minus 1 minus 1 minus 1. So this is minus 2 and multiplied by minus 1, that will lead us 2. So this function is approaching towards 2 when x is approaching towards minus 1. So also clear one thing, that in both of these functions just put x approaches to 2, that was given. Just put x equals to 2 first in that function. 2 square means 4 minus 4 over 2 minus 2, that will get 0 over 0 form if we directly substitute this into function without using algebraic techniques. So why we have chosen this algebraic techniques? Because when we substitute x equals to 2 in that function, and when we substitute x equals to minus 1 in that function, we get undefined, means 0 over 0 form. So to avoid 0, when you are getting 0 over 0 form or undefined, then you will use this method by using algebraic techniques, you can take common, you can factorize if there is a requirement. So this is the way to solve the limit problems by using algebraic techniques. So when you will use algebraic techniques, when directly you will first put the given number in the function. So if it is undefined or 0 over 0 form, then you will use algebraic techniques. So this is the proper way to solve this.